Hello viewers, I'm Kausalya. Today we are going to solve problem 2 in exercise 4.3 quadratic equations. Find the roots of the quadratic equations by applying the quadratic formula. The first problem is 2x square minus 7x plus 3 equal to 0. First we are going to list out the values of a, b and c. The value of a, that is coefficient of x square, is 2. The value of b is minus 7 and the value of c is 3. So this is a quadratic equation, that is the maximum power is 2. So finally we will be having two solutions for this given equation. So here the formula is x is equal to minus b plus or minus root of b square minus 4ac by 2a. So here we know the values of a, b and c. So we are going to substitute. So minus of minus 7 plus or minus square root of b square, that is minus 7 the whole square, minus 4 into 2 into 3 the whole divided by 2a, that is 2 into 2. So minus of minus 7 becomes plus 7 and minus 7 whole square is 49 and 4 2s are 8 and 8 3s are 24 whole divided by 2 2s are 4. So 49 minus 24 gives you the answer 25, and square root of 25, as we all know, it is simply 5. So here we have 7 plus or minus 5 by 4. So we can split these roots. So we can write them as 7 plus 5 by 4 and here 7 minus 5 by 4. So here it is 12 by 4 and 2 by 4, and finally we have 3 and 1 by 2. So the roots for the given quadratic equations are 3 and 1 by 2. Now we proceed with our second question of problem number 2. So here find the roots by applying the quadratic formula. The equation is 2x square plus x minus 4. So first write down the values of a, b and c. So coefficient of x square is a, coefficient of x is b and the constant is c. So here the value of a is 2 and b is, you see the coefficient of x is nothing, so it is 1. So the value of b is 1 and the value of c is minus 4. So the formula here is x is equal to minus b plus or minus square root of b square minus 4ac by 2a. Now substitute the values of a, b and c in their respective formula. So here it is minus 1 and plus or minus, you see 1 square is 1. And here we have minus into minus, therefore it will become plus. So 4 2s are 8 and 8 4s are 32. So square root of 1 plus 32 the whole divided by 2 into 2. So 2 2s are 4. Now when you simplify, square root of 32 plus 1 is square root of 33, and square root of 33 we don't have a perfect number. So we are keeping this as such. So finally the roots here are nothing but minus 1. So here it is, minus 1 plus square root of here. So here plus. So here it is, right? No, here the minus 1 is common, right? Minus 1 plus square root of 33. Yeah, here there will be minus. Minus 1 plus square root of 33 by 4, and here minus 1 minus square root of 33 by 4. So these are all the roots of the given quadratic equation. So now we are going to solve third part of our problem number 2. So find the roots by applying the quadratic formula, and the problem is 4x square plus 4 square root of 3x plus 3 equal to 0. So again just list down the values of a, b and c. So the coefficient of x square is 4, which is nothing but a. Coefficient of x is 4 root 3, which is nothing but b, and coefficient, that is constant term, c is 3. So now the formula here is x is equal to minus b plus or minus root of b square minus 4ac by 2a. So here the value of b is 4 root 3, a is 4 and c is 3. So now just substitute the values here. So here it is minus 4 root 3. So 4 root 3 the whole square. The value of 4 square is 16 and the root 3 whole square is 3. That is 16 into 3, which is nothing but 48. So here Again, you see 4 4s are 16 and 16 3s are, again, we are having the same thing, again 48. So here it is minus 4 root 3 plus or minus square root of 48 minus 48 by 2 4s are 8. So here 48 minus 48 becomes 0. So here we will be having minus 4 root 3 by 8. So when you simplify, you see we can cancel this 4 and 8. So here we will be having minus root 3 by 2. So this is a quadratic equation and here we need two roots but we have only one roots. What does it mean? Whenever the value of b square minus 4ac, that is this part, okay? Whenever the value of this b square minus 4ac is equal to 0, then we will be having two identical roots. So here we have the two, that is the roots are minus root 3 by 2 and minus root 3 by 2. That is, we will be having the same roots, okay? So that is the meaning that we are having identical roots for the given quadratic equation. Now we are going to solve problem 4, right? That is fourth part of problem number 2. Here the question is 2x square plus x plus 4 equal to 0. So again list down the values of a, b and c. So here the value of a is 2, b is 1 and c is 4. Now the value, that is the formula here is x is equal to minus b plus or minus root of b square minus 4ac by 2a. So here just substitute the values of a, b and c. So here we will be having minus 1 plus or minus root of 1 square minus 4 into 2 into 4. The whole divided by 2a, 2 into 2. So here again minus 1 plus or minus square root of 1 minus 4 2s are 8 and 8 4s are 32. So square root of 1 minus 32, the whole divided by 4. So 1 minus 32. Here the answer is minus 31. So minus 1 plus or minus square root of minus 31 by 4. So here in this case, again when you look carefully, here in the previously solved problems, we are having only, that is square root with some positive number. But here we are having a minus sign within the square root. So this means that this quadratic equation does not have any real roots, or we can tell that is the solution for this quadratic equation has imaginary roots, right? So as of now, we will limit our discussion with this, okay? No need to discuss much more about the imaginary roots. So here, whenever you have a negative sign within this square root, obviously it means that you don't have any real roots, and here we are having a imaginary roots. So therefore, finally we can write our answer as, that is no real roots for this quadratic equation. Okay, the value of roots are this one, right? One is minus 1 plus root of minus 31 by 4. And the other root is minus 1 minus square root of minus 31 by 4. But as of now, we are discussing only about the positive roots. So therefore, here we can simply end this problem as no real roots for this quadratic equation. So that's all. If you have any doubt, let me know in the comment section. Thank you.